Hello learners, welcome to TryWrite. Today we will be knowing about the concept overriding and polymorphism. Coming to overriding, method overriding occurs when a subject class, when a subclass, method overriding occurs when a subclass provides a specific implementation of a method that is already defined in a superclass. Now, when a method present in the superclass is also works in the subclass. This is called as method overriding. Now the rules for overriding: the method in the subclass must have the same name and return same type and parameters as the method in the parent class. Coming to the second point, the subclass method must have a more restrictive must not the subclass. how come how come a method can be overridden if it is have more restrictive uh, access modifier. So for overriding, the access modifier not be a restrictive one. The super subclass method must not have a must the super subclass method must not have a restrictive access modifier. Only inherited method can be overridden. You cannot override static method, final method, and private method. So we know that you cannot from now we know that you cannot override static method, final method, and private method. Now key concept of method overriding. Now coming to the key concept, same method signature. The method in the child class must have the same name and return type and parameters as the method in the parent class. So here we know that the method in the child class must have the same name and return type and the parameters as the method in the parent class. For inheritance, overriding requires inheritance. For overriding requires inheritance. Overriding requires inheritance. The subclass must extend the superclass. The subclass must extend the superclass. And third point, at override annotation. This annotation helps to ensure you are actually overriding a method from the superclass. This at override annotation ensures that you are actually overriding a method from the superclass. Now access modifier. The overriding method cannot have more restrictive access modifier than the overridden method. As we talked earlier only, the overriding method cannot have more restrictive access modifier than the overridden method. Exception handling. Overriding method cannot throw exceptions than the method it overrides. Only now coming up to next point, only inheritance method can be overridden. Static method belongs to the class and are hidden or not overridden. Constructor can't be overridden. Constructor can't be overridden. Now we will be seeing some of the examples and understanding overriding method. For this we will be going to the Eclipse. We will be going up to Eclipse. Yeah, here in Eclipse we have the shape class. We have the shape. We have the shape. Yeah, we have the shape. Yeah, shape. Yeah. Here, shape is a class. Shape is a class which has method draw. Shape is a class which has a method draw. We can see that shape is a class, and there it has a method draw. It has a method draw, which is of public form, public, and should not return any kind of value. System, and it is printing drawing a shape. It is printing drawing a shape. Now coming up to the main class, main shape class. Yeah, this main shape class. It is also a class which extends shape class. This is in this class circle class. We can see that circle class extends shape class. So it overrides. So it can override and use all the methods in that shape class. So it is overriding here the draw method here, and it is printing drawing a circle. There we are printing drawing a shape, and it is drawing a circle. Here we are printing drawing a circle. Now the main class having the method main line and forming a shape object of the shape class. Here we have the shape class, and the object is being formed here, generic shape with a new keyword. So calling the generic shape, calling the object dot method name, calling the object dot method name, we can form all those values. We can form the output. We can form the output calling the method object name dot method name, object name dot method name, calling the object name dot method name. Now we have shape class. See, we are forming shape class. We are forming an object of circle class. We are forming a, now this is basically a class. This is circle class. This is extending the shape class. This is extending a shape class. So it is inheriting all the properties of the shape class. So we have to form an object of the circle. We have to form an object of the shape class circle. Yeah, we have to form an object of the circle, circle class, which is inside this shape class. We have to form an object of the circle class, and we have to call. We can call any of the methods in the shape class, following this object, as we are doing it here. Now, when we run this program, we will see the output on the console. Yeah, very well. Shape is drawing a shape, We have seen in the shape class drawing a shape. Wait, shape. Yeah, drawing a shape here. And in the main class, we have the drawing a circle here. Yeah. Now, moving on to here, we can see all these things are very easily available to us. We have got to know that these values, this shape class, there is a super class which is the base class, super class or base class. Super class has the same name as base class. Super class can be called as base class. It defines the method draw. It is defining the method super class, which is the shape class, here, shape class, which is shape class. Yeah, it is defining a method draw. Yeah, circle class, we are forming a other class, main class, shape main. We are forming a shape main class, which is having a shape class, which is having a circle, class, which extends shape class, which is extending shape class, and inheriting the properties of the shape class, and it is inheriting the properties of the shape class. Yeah. Now each overrides of the draw methods using override. We hear it overriding the property of the shape class, that is draw method. Yeah. So it is drawing the circle. It was drawing a shape there. It is drawing a circle here. Now we are now coming out to polymorphism. Now we will move on to polymorphism. Yeah. Now moving on to polymorphism. It allows objects to be treated as instances of their parent class rather than their actual class. It allows objects to be treated as instances of their parent class rather than their actual class. Poly means many, and morphism means forms. In Java, it refers to the ability of single interface to represent different underlying forms. It actually in Java, it refers to the ability of a single interface to represent different underlying forms. The various types of polymorphism are compile type polymorphism, that is called static polymorphism. Compile type polymorphism is also called static polymorphism, and runtime polymorphism, which is a dynamic polymorphism. Runtime polymorphism is also called as dynamic polymorphism. Now compile type polymorphism, this is achieved by method overloading. Where multiple methods have the same name but different parameter list. If we are here, this is achieved by compile type polymorphism is achieved by method overloading, which means they have the same name. They have the same method name but different parameters. And runtime polymorphism, this is achieved by method overriding, where a subclass provides a specific implementation of a method already defined in the superclass. Here it is achieved by method overriding. Here a subclass provides a specific implementation of object already present in superclass, or of an object which is already present in superclass. Now we will be moving on to the example to understand it better. Now for the example part, we will be drawing calculator with polymorphism. overload and override conditions methods. We will be drawing calculator for polymorphism, which will be overloading or overriding calculation method. Here we will draw calculator. We have drawn a calculator. Here the calculator. Here there is calculator, which is having a calculate method. Here we can see that it is having a calculate method. Here the initial values. Here the initial values are int a, int b. In this calculator, the parameters are int a and int b. Here in calculate method, here in calculate constructor, here all the constructor, we can treat them as constructor. Here the variables are int a, int b, int c. Here there are two variables only, int a, int b, int c, all three variables. Here in this calculate, there are two variables but of the double forms, double a and double b. Here in this calculate, there are two variables only, but double a and int b, This is actually the difference. See the difference in the parameter list. Here int a, int b, int a, int b, int c, int double a, double b, double a, double int b. So here overriding is happening depending upon the parameter, depending upon the type and value of parameters, type and number of parameter, number of parameter. Yeah. Now coming to the main method of this class. Now coming up to the main method class. Yeah. Now we have the main method class here. Here we have the main method class here. Here we have to form the object because we are calling one class from other class. Here we are calling calculator class to the calc main. Here we are calling calculator class to the calc main. So we have to form the object. We are forming the object with the new keyword of this calculator class. The superclass. We are forming the object of the superclass with the help of new keyword. Yeah. Now we have to now here it is doing system.print basic calculator. Now basic here when we are passing the value 5 and 5b, 5a in basic object dot this method, object dot calc method, but we are passing we are calling constructor object dot calculate constructor, but we are passing two variables 5 and 10. Here 5 and 10, we are passing 5 and 10, and we are getting the value. Now we are getting the value of 15. When we run this program, you can see the output. Yeah, 15. Here both are added. Now here there is advanced calculator. There is advanced calculator. It is printing the values advanced dot calculate for 5 into 10. Now it is multiplying the values. Now multiplying the values 5, 10 into 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 5, 50, 10 into 5, 50. Yeah. 10. It's very much clear that it's 10 into 5, 10, 50. Now coming up to this part, basic system println for the three integer part, 1 to 3. We have the three integer parts, int a, int b, int c, and now all the three integer values were added. 1 to 3 were added. 6 was the final outcome. And now here for the overloaded double parts. We have the two values double a, double b. We had the two values double a and double b. So we can see that added values are very much easily visible here. Here the method overloading. For the method overloading, calculator int a, int b, int a, int part, calculator which is having the parameter int a, int part, and calculator which is having the double parts, double values. And now there is three integers values also. This is the method overloading part. Which is taking place. Now coming to the polymorphism part here. Yeah, we can very well see that operation type, calculate and operation type resolve based on actual object at runtime. Calculation type and object, here we can see operation type and calculate can resolve based on actual object at runtime. Now thank you. We will meet in the next class. Thanks. We will